Let's start our course of network security. Today, our lecture number 4 on the topic, a model of network security. Under this topic, we will be discussing why this network security model is required and what are the important terms that are used in this model, component of security model. For example, if we want to design our own secure mechanism, so what model needs to be considered? So it will help in understanding those component of security model and model for network access security. That how the model will be used. So let's start with why network security model is required. So when an opponent possesses a threat to confidentiality, integrity, availability, and authenticity, we need a model to make your data secure. So as we have discussed all these terms in our class, but for the sake of understanding, I'll explain it again. Confidentiality means authorized user have access, only authorized user have the access to that data. Integrity means no changes have been made over the network. And availability means data must be available to authorized user only. And authenticity means authorized user is verified before access is granted. So these are the terms. Before starting our security model, we need to understand these. Let's start with first one, like plain text. Plain text means that in which you send your information or what you want to send to your receiver. We call it as a plain text. When you convert the plain text into unreadable form or the form which is not understandable to an opponent, we call it as a ciphertext. Encryption means when plain text is converted into ciphertext, we call this process an encryption. The reverse of this is called decryption. In decryption, you have a ciphertext, and from the ciphertext, you will get your plain text. We call this process the decryption. Cryptography means, crypto means secret and graphy means writing. So secret writing. Actually, the ciphertext, the art of making this ciphertext is the cryptography actually. Cryptanalysis means that art of deciphering cipher without knowing the key. Actually, this is the art which normally knows by the opponent to get your cipher information, and the key through which you are made your data is made as cipher or converted into cipher. We call it as a key. So normally this is provided by the third party or an angel. Using that, you will convert your plain text into ciphertext. So there are different type of keys. We will be discussing all these in our in this class as well as in our coming classes. Basic component of security model, like all security technique, must have the following two components. So in order to design a secure model, you have to follow these two components, or you must have these two components. A security related transformation means that encryption will be required. You have an algorithm which will be converting your plain text into ciphertext, and we know that this process is called encryption. And secret information shared between sender and receiver. That how this cipher will be created, this will be based on some key. So this will normally be provided by a third party. So secret key information shared between sender and receiver. Normally this is done by a third party, and key will be given to them in order to perform the process of encryption on the sender side and decryption on the receiver side. And actually, who will share this key, normally we use third party for that. Now, this is the model which we need to discuss, that security model actually. For example, if let me take a marker here. Spotlight it like this. For example, you have a message here, and this message will be in a plain text which you want to send to your receiver. So here you see security related transformation will be required first. You have some you have some kind of algorithm here, and then you have a secret information which we discuss as key, that this key will be provided to this plain text, and then this plain text will be converted into secure message. Means now the message is converted into cipher text, and then this message will be sent over the network. This will be a private or a public network. So using this channel, the secure information will be sent to the receiver. Receiver will get this secure message, and then the receiver will perform the reverse operation, like security related transformation, the same algorithm which is applied by the sender side, and the key which is provided by the receiver. This will be applied, and you will get your plain text out of this cipher text. So now I think you can understand that on a sender side you need encryption, like this secret key and security related transformation. Here we call the encryption process will be applied, and after encryption process you get cipher text like secure message, and then on the receiver side reverse operation will be performed, like your secure message will be secure message like cipher text message will be again converted into plain text. And how and who will provide the secret information or a key? This will be provided by the third party. As we mentioned, that third party will be there, and this third party will be providing the information to the secret information to both sender and receiver. Let's take an example. Like for example, you want to send hello to receiver. So this will not be sent as hello, because if this information is received over the network by a malicious or unattended user. So for example, if a sender wants to send hello, so it will be converted with some kind of like H, and like for example E and hello, and like this will be converted into this, and this will be sent over the network. So user will, if the opponent is there to get your information over the network, he will not be able to understand what you want to send to your receiver. So this is how you can you can get your message secure. So when receiver receive this information, so receiver knows as this is already been negotiated between sender and receiver through the third party, that how the message will be encrypted and how the message will be decrypted. So at the end, receiver will be able to receive the message, which will not be altered or will not be modified by any opponent over the network. Let me clear all these designs. Now let's go to our, let me clear all these. So now So after understanding this model, now we understand that what this model requires us to do. As we know that if we want to design a secure mechanism, we need to follow this model. So design a suitable algorithm for the security transformation. As I mentioned that here we are discussing that what type of algorithm will be required, as we have seen in the model, that we have a secure transformation. Secure transformation was required. So we mean by algorithm. So there's an algorithm is required for the security transformation, and then generate the secret information. As I mentioned that this is normally a key which is provided by a third party to both sender and receiver to perform the process of encryption and decryption. Develop a method to distribute. Definitely this method should be devised, that who will provide and how it will be provided securely to both sender and receiver, because this is the most crucial thing, that if the intruder or the malicious user get this key, so he can easily decrypt or understand your messages. So you need to devise this mechanism as well, that how securely this key will be shared between sender and receiver. Specify a protocol enabling the principal to use the transformation and the secret. Normally, some kind of secure protocol will be required, like we have a TCP or UDP, or like some other protocols which are required. So using those, you can make your algorithm on it. Now this is access security, that how you get the access to the information system. Like you have an opponent, and opponent means if he is a physical user, like he is a cracker, or a software like virus or worm, and he get access to the channel. So you must have a gatekeeper or a firewall or a router. Normally you give him a kind of SOPs. So on the base of this protocol or SOPs, it works. It works and only allow the authorized users to get the access to information system. And if he doesn't recognize the user, he denied the access to that user to the information system. On an information system, you have a computing resources, a processor, memory, input, output, or a data processes, softwares, or internal security controls. So these will be provided. So the gatekeeper will be responsible here for allowing access to the information system. Using this model requires us to select appropriate gate function to identify user. Definitely, as I mentioned, that you have to give some give the gatekeeper some SOPs or a rules, that on the basis of which he identifies authorized user to allow him access to the information system. Implement security control to ensure only authorized user access designated information or resources. Actually, if you give this control to the gateway, so the gateway will allow the user to get the to check the user or check his authenticity before allowing him to access the information system. Trusted computer system can be used to implement this model. Definitely, as you know, that trust is the most important thing, that your trust and security must be there. So, so that unauthorized or malicious user cannot get the access to that information system or a gateway. Otherwise, he can he can use your system harmfully. So these were the reference books we have already discussed in our classes, but these are the books which you need to follow. All of these books can fulfill your objectives of the course. Actually, I am following Cryptography and Network Security, written by William Starling, but you can follow anyone out of this list. And in the next class we will be discussing different kind of models and different type of techniques. So we will meet in next class. Thank you.